Hello everyone. Today we're going to start our unit on geometric transformations. So in geometry, a transformation is an action that changes the size and or location of a geometric figure. The figure that could be a single point, a line segment, or a shape. One or more transformations are applied to what we call a pre-image, or the first shape or image that we start with, and the result is called the final image. We will be learning about 4 different transformations in the next few weeks. The first one that we're going to learn about is translations, which is today, and then we'll move on to reflections, rotations, and then dilations. So the most important thing that you know is a transformation is the changing of size and or location of a figure, which could be a line, a point, a line segment, or a shape. Then, when we are moving on to translation, when I say translate something, that means you are moving it or sliding it in the same direction, same distance. So you can go up, down, left, or right. You can also do a diagonal translation, which is a combination of the horizontal and a vertical translation. Below are the key points regarding these types of translations. So a translation does not change the size or shape of a geometric figure, and they also do not flip or turn the geometric figure. So it is going to end up pointing the same way every single time. It's going to move up, down, right, left, or kind of like a diagonal when it's a combination. In each case, below, we are going to determine if the figure is a translation. Figure 2 is a translation of figure 1. Explain your thinking. So we have figure 1.
Here's what I found.
It is the exact same size, and it is the exact same shape. The only difference is that instead of it being on the left side, it has moved over to the right. So this does constitute as a translation because it is the same size, the same shape, and same direction. The only difference is its location. Okay, for example number 2, we have the original pre-image 1 that is pointing up. Now we have an image for the result or the final image, it is pointing down. So in this case, this is not going to be a translation because the direction of the arrow has changed. It has not slid up, down, left, or right. What it has done is actually turned. So this is not a translation. Okay, and then this last one here, or not last one, sorry. Letter C here, we have image 1, and then we have image 2. It is pointing in the same direction, meaning it went up and left and changed the diagonal a little bit, but the direction in which it's pointing is different. So it hasn't just moved right and then down, it has actually moved kind of diagonally, and then it has also made smaller. So when it was made smaller, that means it is no longer congruent, which means same size, same shape. It is now smaller. So no, the size is different. And then the last one here, letter D, we started with image 1, which is on the far right, and then we ended with image D, or image 2. So it went down, and it went to the left. So it is still the same size, same shape, same direction. The only difference is that its location has changed. So I'm actually going to go back up here, and I'm going to copy this, and I'm going to paste it down here because it is still the same true situation. It is the same translation, same size, same shape, same direction that the arrow is pointing. The difference is the location is no longer in the upper right-hand corner of our paper. It's in the bottom left. If we have 2 figures that are congruent, that means that they have the same size and same shape. So it's important that we know congruent has to be the same size and same shape. Okay. So down here, does applying a translation to a pre-image produce a congruent final figure? Yes, it does. And the reason for that is because the size and the shape has not changed. Only where it is located has changed. So go ahead and write that down there. Again, yes, applying a translation to a pre-image produces a congruent final image because the size and shape is the same. The location is just different. All right. So down here, we have a coordinate plane. And I know it's a little confusing with the numbers on the outside, but it was so that you could see things a little bit better. So we're going to start with our pre-image. And it says translations can be performed on the coordinate plane. Each translation includes two components, a direction and a length. Follow the directions below to practice translations on the coordinate plane. So for part 1, it says plot the point 1, 3. This is the pre-image. So remember that we always have x come first, and then we have y. Our x goes straight across, and our y goes up and down. So when it says 1, 3, I'm going to start at 0, 0 and go over 1 and up 3. I'm only going to put a point at 1, 3. I'm not going to put a point at 1 or a point at 3. I'm going to put it at that. And I'm going to label this point number 1 just so that we can see that is point 1 so I know where I'm going. Now I'm going to change colors. That way you can see the difference between these. So for part 2, it says translate the point 1, 3, 4 units down. Plot the new point on the plane above. What are the new coordinates of the point? So I'm going to start here, and I'm going to go down 1, 2, 3, 4 points. And I'm going to put my point right here, and I'm going to label that number 2. My x always comes first. It did not change. It is still at 1. But my y value is now at -1 instead of 3. Okay. My next point, it says translate the original, the 1, 3, 8 units to the left. Plot the new point on the plane above and state its new coordinate. So if we go from number 1 and we're going to go to the left 8. We go 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put a point here. I'm going to label that number 3. So in this case, our x value changed to -7, but our y value stayed the same at 3. Then our last one here, now translate the original 1, 3, 2 units to the right and 3 up. Plot it on the new plane and label the new coordinate. Okay, so 1, 3, I'm going to go to the right 2, 1, 2, and then I'm going to go up 3, 1, 2, 3. So here is my new image, and I'm going to put the number 4 there. So my new ordered pair, my x comes first, 3, and my y comes second, and that is at also 1 at 6. There we go. So if you notice when you are graphing this on your own, you can tell that when it goes left or right is the x value that is changing. When you go up or down, it is the y value that changes. And that is because the x-axis is horizontal, left, right, and the y-axis is vertical, up and down. All right, so here we go. Sometimes we use prime notation when we talk about the pre-image and the final image. So when we talk about that, we have triangle ABC, so we would plot that. And then when you see the actual little lines here, these are called prime marks, okay? So when we talk about prime notation, we are talking about when it says A and then it looks like an apostrophe, B apostrophe C apostrophe. That is called prime notation. And basically it's so that we don't have to write ABC and then A1, A2, B2, C2. So we are going to go down here and we're going to actually plot these ordered pairs. So letter A, it says is at -1, -1. So that means I go left 1, down 1, and this is my letter A. Letter B is at 0, 2, so 0, and then straight up 2. And then letter C is at 3, 0, so I go straight over 3, up and down nothing. And now I'm going to connect these, because it says that it is triangle ABC has vertices of these points. Vertices are just our points, the edges where two edges meet. Okay, So we have plotted the triangle. Now we're going to translate ABC 2 units to the right and 5 up. So what that means is I'm going to get out, I'm changing my color. So I am going to take every single one of these. So starting with letter A, I'm going to go to the right 2, and then I'm going to go up 5. 1, 2, 3, 4, 5. And I'm going to write that as A, and then I'm going to put that little line next to it, A prime. So when I look at that, I'm going to go do B the same way. I'm going to go to the right 1, 2, and up 1, 2, 3, 4, 5. So we have letter B prime. And then we're going to do C prime. Go over to the right 1, 2, and up 5. 1, 2, 3, 4, 5. And then again, we're going to connect them. Now, you do not have to keep those little blue points that I have on there. If you see them, they were there for me to help count. You do not need to keep those at all. Now, for part C, so we've done part B. Part C says, write the new ordered pairs. So if we look at A, it is to the right 1 and up 4. So we have the ordered pair 1, 4. Letter B is over to the right 2 and up 7. So our ordered pair is 2, 7. We always do X and then Y. X, Y. And C prime is over 5 and up 5. So 5, 5. Okay. So when we are looking at these figures, we have to remember that these are congruent. They are the same size. They are pointing in the same direction. The A is in the bottom left-hand corner, B is at the top, and C is on the right-hand side of our triangle. If we don't have that, that means that it's not congruent. It didn't stay the same size, it didn't stay the same direction, and it didn't stay the same shape. So here, when we are looking at these, it says determine the translation of figure 1 to obtain figure 2. The figures are congruent, okay? So we already know these figures are congruent. That means that they're the same size and they are the same shape. What we need to figure out is what actually happened between image 1 to image 2. So if we look at this point right here on image 1, and then we look over here at this point on image 2, it looks like I just slid it over to the right here. So in order to know that entire translation, I have to count how many spaces did I actually go over. So I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm going to try that also with the point up here in the upper right hand corner. I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so since I did go 10 both ways, that means our whole shape is the same shape and size. We already know that. So it was over to the right 10 spaces. All right, this next one here, if we pick this point right here on the bottom part of our triangle, and we pick, and we pick this point over here on the bottom of this triangle. Remember, we're talking about pre-image 1 to pre-image 2. So I have to start here at the blue point, and I'm going to go over to the left 1, 2, 3, 4, 5, 6. So that meant I went 6 to the left, and then I have to count how many to go up. 1, 2, 3, 4, 5, 6, 7. So we went up 7. All right, so our units here were left 6 units, up 7 units. And the reason I knew to go over to the left 6 is because I got it to the point that it was lined up with the green dot, and then I had to go up to meet it. And you always need to make sure that you're always going from image 1 to image 2. All right. What patterns can be used to obtain the corrected ordered pairs after translations are performed? Explain your thinking below. Well, if you find one point that matches up with the other point, we know that equals the same thing. I could actually draw over this triangle right here. And then if I pull it over, I go over 6 and I go up 7. See how they are the exact same size, exact same shape. The only difference is that it was up 7 and to the left 6. Okay. So that is what that discussion question is talking about. Now there is another way that we can represent translations when we are talking about ordered pairs, and that is known as symbolic representation. So symbolic representation is when they put a plus or minus a number next to the x or y or both values. Positive values A and B represent the up and right. Negative values represent down and left. So when we talk about it, remember that x is going left and right. So when we see it saying positive 3, that means we are going to the right 3. Because if we look at a graph, positive 3 is always going to the right for the x values. When we see a negative 5 for the y, that means we are going down 5 units. Again, that is simply because on the y-axis, if you are going to negative 5 or going minus 5, it means you're going down, not up. Now, if we look at this one says negative 1, x minus 1. So that means we are going to go to the left 1, and it says plus 2 to the y. So that means we are going to go up 2 for the y. So each ordered pair in the figure would be translated accordingly. So if we see that we have 3, 8 as our original point in the figure, and we add 2 to the x, that would give us 5. And if we subtract 4 from the y, that would give us 4. So our new ordered pair would actually be 5, 4, because we added 2 to the x and we subtracted 4 from the y. All right. So now we're going to look at this. It says, without graphing, write the symbolic representation of each translation below. Okay, so whatever we see up or down, this means we are affecting the y value because the y-axis goes up and down vertically. So the x is going to stay the same. We're doing nothing with it. It's not going left or right. So it stays as x. And then the y, since we are going up, is going to be plus 4. When we are looking at letter B here, it says we are going to the left 3. And if we look at a number line, left means subtraction. Okay, so we are going to subtract 3 from our x, and we are going down 1 for our y. Y minus 1. Again, the reason we're subtracting 3 when we go to the left is because if we look at the x-axis, if you are going negative, that means you're heading towards the left. When you are looking at the y-axis, if you are going down, that means you're heading to the negative. So you're subtracting, getting smaller. Okay, so now all we have to do this time is look. They gave us the original xy. Now we're subtracting 6 from the x. So if we are subtracting 6 from the x, we are actually going left 6 units. For part D, it says add 5, so that means we're going to the right. And we're going to add 4 to the y, so that means we're going up. So right 5 units. And up 4 units. Okay, so down here, we are going to complete example number 5. This is our last example on our notes. I'm going to plot triangle ABC given the coordinate plane. Okay, so -1, -1 means left 1, down 1. I have letter A. Letter B is at 0, 2, so straight up 2, letter B. And letter C is still at 3, 0, right here. Then I'm going to connect them with straight lines and make our triangle. Oops. Okay. So we have our triangle made. Now we are going to add 4 to our x and subtract 2 from our y. So what we literally could do is take our A ordered pair of -1, -1, and we could add 4 to the x and subtract 2, which would give us 3, -3. Okay, so we know our ordered pair is 3, -3. The other thing that we could have done is taken our A value, and we know that we're adding 4, so that means up 4. 1, 2, 3, 4. And I'm going, oops, sorry, I went the wrong direction. Not going up 4. I'm going to the right 4. 1, 2, 3, 4. And then I'm going down 2. 1, 2. So this is my new value, A prime. So A prime is at 3, -3. And I already figured that out mathematically as well. So I know that I have the right point. Now, this next one, instead of figuring out the right point ahead of time, I'm just going to go to the right 4 from my B. 1, 2, 3, 4. And then I'm going to go down 2. 1, 2. So my new letter B, or B prime, is right here, which is at 0, 4. I can always check that by taking my original 0, 2, and I can add 4. And, oops, sorry, I wrote that wrong. 4, 0, not 0, 4. There we go. Caught myself there. Okay, so I add 4 to my x, and I subtract 2 from my y. So this would give me 4, 0. I don't know if any of you else caught me before I did that. Great job if you did. Good job paying attention. All right, last part, last one. For letter C, it means that we are going to go to the right 4. 1, 2, 3, 4, and down 2. 1, 2. So here is letter C prime. I'm going to connect it as my triangle. It is still the same shape, same size, and same direction. The only difference is its location has changed. And that is now at 7, -2. And those are the notes for today. Please make sure that you are actually taking notes yourself. That way you are able to double check and use those on your test for this unit. I am going to allow you to use your notes, so I want to make sure that you have good notes to follow with. It'll make it much easier for you to double check your notes, go back, check things before you actually answer your questions on your test. If you have any questions, remember to email me, and I hope everything is going well for you, and I look forward to seeing you on Zoom.